Hello. Okay, may buntag sa tanan. Nalika ko ang kabuntagon. First of all, we would like to thank everyone for coming. Please, the power of social media. We just had a tragic event last Sunday, and as you know, the SIAD, the Structural Engineers Association of Davao, organized a similar seminar last October. So, but there were about 100 who participated, and we wanted as many Davaoenos, and of course, Mindanaoans, to be able to learn and expand the knowledge, learn more about capital assessment, and help more the Mindanaoans. That's our primary objective. So, without much ado, let me first introduce our resource person for this seminar. He's currently a doctoral candidate in geotechnical engineering at Mindanao State University. He finished his Master's of Science in Civil Engineering, majored in structures, as a grantee of DOST scholarship at UP Diliman. Finished his bachelor's degree the University of Immaculate Conception, graduated as magna cum laude. Hindi na ako kaya si Sir. I'm also an alumni here of UIC. We are both top-notchers coming from this university. As a person who loves to teach, he was formerly a lecturer in the Engineering and Science Department of UP Diliman, Dean of the Engineering Program of UIC, instructor of the graduate program in Ateneo and the University of Mindanao. He is the founding president of SIAD and a member of ASEP. Of course, you know, everyone knows here ASEP. Formerly, he was the president of PICE Davao City Chapter. He is also an accredited specialist in structural engineering conferred by the PICE. Presently, he is the president of QSTI and AE BOTUYAN Construction and Structural Consultancy, as well as Concretech Incorporated. Ladies and gentlemen, let me introduce to you Dr. ALLAN BOTUYAN.
Thank you very much, Jack. Thank you very much. I'd like to congratulate the participants because you acted in a very short notice, because we know as civil engineers, we have a responsibility to do, especially after the recent earthquake last Sunday. So I just like to see a show of hands. Who among you here are from outside of Davao City? Specifically outside Davao City, okay? Anong lugar? I know, Arnel is from Cotabato, Arlene is from Tago. Sino ba yung place na no? I just like to see, no? Okay, from what place are you, ma'am? Sultan Kudarat. So, palakpakan natin siya. Just like to see this. Igapawan, North Cotabato. Taas niyo bang kamay niyo so that we will see. Yes, sir. Where are you from? Davao del Norte. Okay, from Australia. Dito pa na side. Tagum. Okay, Tagum, Davao del Norte. Meron pa akong nakita dito. Okay? Wala na from outside Davao City. Okay. Mako. Malang. Okay, so North Cotabato. So, wala na from outside Davao City. Okay, so congratulations, and to those who are in Davao City, palakpakan sa inyo because you are dominant number here. Okay, the reason why the Structural Engineers Association of Davao saw it that we have to do our part, especially at these tragic moments. And before I proceed to the assessment proper, I know many of us in here, especially engineers. Meron bang hindi engineers dito? Just like to say, okay, si ma'am, ano pong field niyo? Nurse. Okay, kayo po ma'am. Yes, ma'am? Educator. So may nasa academic, yes, sir. Doctor. So medical doctor. Wow. So, nakakatuwa talaga na. Palakpakan natin sila, no? The last time I had a lecture in Notre Dame, Kinabawan, 50%, or I think almost 50% of the participants were from DepEd. So mga educators din sila because they were mandated to check their buildings and then they were shocked. Paano namin i-check yung building? We don't have the capacity. So they attended. So they were more than 142 participants during that time. So going back to what I said a while ago, many of us engineers here, no? Maybe meron kayong pinonstruct ng mga buildings that either stood the shaking or naapektuhan kayo and you were a little depressed. So this is not the time to blame anyone. So for those who have designed and constructed buildings that withstood the 4 major earthquakes in the past 2 months, we would like to thank God for you for doing your job well. But for those of you who have inadvertently missed something, we are with you. No? Kung medyo naapektuhan yung mga structures na ginawa ninyo. We are not here to condemn anyone, but we are here to encourage one another and to learn lessons so that the next time we make buildings, we design the buildings, and we construct the buildings, we will do it with all of our heart, mind, soul, and strength. Dahil every time we see a building, our souls and our persons and our character are also in it. And if you remember, in the Civil Code Article number 1723, that we engineers are liable and responsible for that building for the next 15 years, the moment we sign those documents. So we are here in this together to help one another, not only to help one another, but to indirectly help those who will be greatly affected by our profession. So okay ba yun? So we are not here para maging malungkot tayo, maging melancholic, maging gloomy, but we are here to move forward and do what we can for the coming days because we really have a lot of work to do. Okay, so for that is now the introduction. So I just like to ask from you, sino ang walang post-earthquake rapid structural assessment form? Kung meron na lahat, kindly wave at me kung meron na lahat. Okay, so I think majority, not all, meron. So kung wala, you raise your hands para mabigyan ka ng form. By the way, okay, meron dito sa harapan, may participant dito sa harapan na wala pa kayo legal copy. By the way, this is actually the form we use in our company, and because there were so many calls na tawag sa office namin na for assessment, ganito, ganyan, so we donated this to SIAD, to the Structural Engineers Association of Davao, and SIAD decided that this will be distributed to as many engineers who will do assessment starting today. So this act of kindness, we hope and pray that it will go a long, long way. So alam natin na inside every person's heart, there is always that desire to be kind and to help other people. So okay ba yun? So sana ma-infect tayo lahat, no? Starting from the community of civil engineers. Okay, so this is actually a SIAD form na, no? So once we gave this to the organization. Okay, so ano muna tayo? A little overview how to use this document. A rapid assessment basically is to answer whether the structure is safe for occupancy or not. So an assessment or a rapid assessment basically answers whether the structure is safe for occupancy or not. And the next question is, how safe is the structure for occupancy? If not that safe, can we enter it up to a certain level or are we totally off limits? So para ma-simplify natin, that's why we call it rapid, because we need an answer immediately. Okay? We need to answer the question immediately, so that's why we have this form. Okay, kung titignan ninyo, we'll go at the back portion first, so page 2. Okay, you see there, makita niyo yung page 2 dito, category of assessment result and recommendations. So each person who will be doing this, okay, you can reproduce this kung gagamitin niyo ito kung saan kayo mag-assess. You will see there 3 large squares. Okay? Tatlong large squares. First square is level 1 or safe for reoccupancy. So safe for reoccupancy meaning after you inspected the structure, you will just check the box. Okay, number 2 or level 2 is entry with caution or the building is restricted not to be occupied immediately. So ito yung sinasabi ng entry with caution. So there is another square or there is another box that you will check once it falls on that category. And number 3 or level 3 is off limits. Ibig sabihin, the structure is dangerous or is in a situation that it may cause harm or further damage. Okay ba yun? So tatlo lang. So once you have made one of the boxes checked, so tapos na yung assessment ninyo. Yun lang. Then you can now make your conclusion or you tell the person or the owner, the building manager that the building is in one of these classifications. Okay, so I just like to know who among you here have already attended the previous lecture on rapid assessment conducted last November in our office in USTI. Sino bang naka-attend doon? Okay, meron na naka-attend. Isa lang, okay. Meron pa sa likuran. Nung mga, nung nakandak doon sa Pinapawan, meron bang naka-attend na rin doon? Wala, okay. I think there was a rapid assessment seminar conducted by ASEC also. Sino naka-attend doon? Okay, meron isa doon. Okay, okay ba yan? Wala namang competition to eh. As long as people are helping, we are really very glad with people attending as many seminars as possible. Doon naman sa PIC, I think there was one that was conducted by PICE. Okay, meron dito. Okay, so ito ang gagawin natin. Since the real assessment, kailangan meron tayong uniformity. That's why we created this form. No? So since we've been doing this in our company, doing assessment left and right since October 16, even up to now, so we want as many engineers here in Davao and even in the entire Mindanao to really be able to conduct assessment not as detailed as possible but as substantial as possible. Kahit pa hindi ka engineer, kahit pa itong gawin, kahit pa educator ka, kahit pa doctor kayo, you can do this when you apply this form. Okay ba yun? Okay ba? So can I say, if I say okay, you'll say alright? Alright. Okay. Alright? Okay. Ayun. Ginaya ko yung anak ko kahapon sa ilang Christmas party. Pag sinabi ko okay, you say alright. If you say alright, okay. Okay. So, tuloy tayo. Now, in earthquake, we just like to look at itong first na form. Kasi ito, I think this is the first kind na gagawin natin na ma-apply natin. So when we enter a building, first, before you enter a building, any structure that is subjected to an earthquake will experience swaying. Now, regardless kung ano yung initial characteristic of earthquake, just like December 15, 2 o'clock to 11 in the afternoon, if you notice that the nature of the earthquake was more of a vertical characteristic than horizontal sway. That means it's really very, very strong. But regardless if the structure is shaken vertically and then horizontally, the most critical stress generated during an earthquake is always the horizontal shaking or the lateral shaking. Now, majority of the building around Davao City and in nearby provinces is made of a moment-resisting frame. Okay, moment-resisting frame. Meron tayong tinatawag na ordinary moment frame, meron tayong tinatawag na special moment frame. So, ano ito moment frame? For the sake of those non-technical people, a moment frame is basically a lateral resisting structure which derives its strength on the joints. Joints. Okay? So, kung titignan natin itong building ng UIC, okay, I've been teaching here since 1987 for about 17 years. So, itong building na to, ito yung tinuturuan namin, no? This is formerly a laboratory. So, the joint is, if that is the column, yung merong emergency lights dyan, yung merong speaker doon, yung emergency lights, if that is the column, the beam that is connected to that, okay, the beam that is connected to the column is what we call a joint. Okay, that is a joint. Now, the strength of a structure resisting the shaking is resisted by that joint. So, any structure, whether it's a beam or a column, will be resisted at that joint. Okay, simula na tayo mag-drawing. I hope those who are seated at the back will be able to see my drawing. I'll just draw a little bigger. Okay? Okay, siguro dito, no? Anyway, I'll just draw it a little bigger. Okay? So this is a joint. This is now a joint. Now, in every joint, it is connected, or it is connecting a beam and a column. Okay? All the moments, for those of us who have passed strength of materials or mechanics, if it is a fixed end, meaning this is not free to rotate, all of the reactions will be concentrated on this joint. Okay? Kapag mahina yung joint mo, okay, if your joint is very weak to withstand earthquake, this joint will tend to explode. Or, if not explode, tend to expand. Mag-expand yan siya. So if there is no confinement, meaning if there are no steel reinforcement confining the joint, okay, whether it's like that or like that, coming from the columns, the beams, intersecting, and there are confinements there, this will naturally explode or crack. Because this is where all the stresses are concentrated when there is a shaking. Now, if it is confined, okay, pupunta yung stress natin where there is least resistance. Okay, dahil nandun yung unang concentration, hahanapin ngayon ng force, sino ang weaker. It's just like a pack of wolves attacking a sheep. Pag merong safety doon, yun yung unang yan ita-target. Yung malakas, hindi niya yung hahabulin. Hahabulin na lang yung medyo mahina. So if there is now a strong ground shaking, if the beam is really weak, then this is the nearest component of the beam closest if the beam is weak. If the column is weak at the same time, assuming the joint is strong, surrender, weak yung metal bend. Okay, balikan natin. The beam is weak. This portion here, near the column or the joint, be weakened or will be showing signs of distress, which is in the form of cracks. Okay? If the column, okay, kaya nito, if the column is weak, then this portion here will show signs of distress. So if we are to inspect, because understanding that the structure is a moment-resisting frame, the strength of the structure is again dependent on where? Ano yung word natin kanina? Saan yung strength niya galing? Joint. Okay, very good. You really listen. So nandoon siya sa joint. Okay? Kapag malakas yung joint, it's either the beam or the column yung damage niya. Okay, never mind the walls first. Titingnan lang muna natin itong beam. Now, there is what we call a design philosophy, strong column, weak beam design philosophy. Strong column, weak beam design philosophy. It simply means that during any damage, it is the beam that will be damaged first before the column. Because once the column is damaged first before the beam, then your structure is next to useless. So that's what happened in Padada. So yan yung pinaka-center ngayon is a strong beam, weak column design philosophy. So when we will be designing our structure, it should follow a strong column with beam structure. And I know you have seen so many structure na yung mga poste, sila yung bumibigay instead of the beam. And sometimes may mga beams before the columns. So when we do inspection, we always look at these portions. Okay? Joints, the beams and the columns. Most likely, dahil na karamihan ng mga dinidesign does not follow the strong column with beam design philosophy, karamihan ng damage are in the columns. Okay, na kung titingnan natin dito sa taas, if this is the second floor beam, if there is this damage here, because of the swelling, it is always coupled with the damage on the other side of the beam. So, ang ibig sabihin nun, magkasintahan yan sila o mag-asawa. Ayan, ito din. Salamat. You read my mind. So, ibig sabihin yan, pag nag-i-inspect tayo, almost often, mag-pair yan siya. If there is a damage, on this side of the column, meron din yan siyang partner dito. May damage din yan. So, sabi pa ng Bible, always, when God created things, they always come in pairs. Meron male, meron female. So even in damages, mag-partner din yan. So kung may damage itong poste dito sa kabila, almost often, 99.9% damage itong sa kabila. Okay, so mag-asawa talaga sila. So when we have an inspection of any building na magkatabi, or any column na magkatabi, like for example, this column and this column, pag meron siyang crack doon, almost often, may crack din yan sa kabila. Okay? So kung i-extend mo ito papuntang ground floor doon, okay? Now usually, sa ating mga engineers, we design buildings like this. For example, andito yung footing natin. Okay? Tapos, meron tayong slab dito. This is now our flooring, and this is our footing. Now, because of the slab here, So there is what we call a temporary or a soft fixity here. But when we model this or when we design this, this is the location of the moment, the greatest stress or the bending moment, and at the same time, here. So pag nag-sway yung building natin, okay, you assume that there is now a swaying of the building here, back and forth. If this column is weak, okay, if this column is weak, this will be overstressed. Itong zone na yan, and again, as I mentioned a while ago, they come in pairs. This will be stressed. But sometimes we do not see that there could be a damage here sa baba. But because there is a slab here, so there is now a restraining of the movement at this point. So if this is well compacted, inayos na pag-compact talaga, so what happens here is, the soil is trying to hold this one so that the stress is no longer here but transferred at this level. So what does that mean to say? We have to check the top level of the column and the bottom level of the column. So okay ba yun? So titingnan natin ito dito, then titingnan din natin sa baba. Then we will see that most likely if there is a heavier damage here because this is laterally restrained a little, there is most likely smaller or less intense damage sa baba. And again, they come in pairs. So far, so good? So okay ba? So you imagine yourself going outside and then checking for an assess or a building. So pag tinignan natin yun, titignan natin anong nakikita natin sa columns. Never mind the walls. I will explain later because they are not structural in nature or structural damage in nature, but they are non-structural. The most important thing is when we assess, we have to look at the columns first for reasons that many buildings were designed with strong beam, weak column. Okay, but if there are strong columns with beam design, makikita natin it's always the beam that will be damaged first. Okay, now let's go to the form. Okay, structural elements. Please check the appropriate box or boxes. Tingnan natin. How do we use this? So in the columns, makikita niyo meron doon sa horizontal line, horizontal cracks, diagonal cracks, X cracks, exposed rebars, buckled rebars, then 1 pp. Now this is in ascending degree of damage. Okay? So kung mangyayari ito sa isang structure, this is the order of the damage in the structure. If the structure is a little stronger, so maaaring horizontal cracks lang siya. And if it is a little weaker, it will be propagating to diagonal cracks. And if it is less stronger, magiging X cracks siya. Tapos next is exposed bars, buckled bars. Okay. Now, titignan naman natin ito dito, merong ABC before, the location, no? Within the upper 1/4 of the height. And then, within the lower 1/4 of the height. And letter C, within mid-height. Okay, let's understand this. So first, within the upper 1/4 of the height. So pag nag-inspect ka ngayon, so if this is your height, okay, kahit na hindi tayo engineer, we know what is 1/4, what is 1/2, and what is mid-height. So pag sinabi mong upper 1/4, so we're talking of this one. So if this is the height of your structure, the upper 1/4 is this one. And the lower 1/4 is this. Okay. Kita niyo yun? So, madali lang maghanap. And then, the mid-height. So, we know that the mid-height is whatever is left within. Ito yung upper 1/4, lower 1/4, and within the mid-height. So titignan natin ngayon, ano itong horizontal cracks? Now, many of our construction methodologies, ito ang ginagawa that we really need to change this practice already. Okay, what are these practices na ginagawa natin?